All right, cool. So yeah, welcome to the MacX Build Endless Runner workshop. So today I'm going to take you guys through how to make a 3D game using Unity and C Sharp. So it'll be an endless runner type game. I'm sure most of you have played like something like Subway Surfers or Temple Run or anything like that. So it'll just be a game that's similar to that sort of an endless runner style built in Unity. So that's the workshop for today. But a quick intro to Mac first. So Mac is Monash Association of Coding. So we're a club that basically focuses on developing skills for the technical industry, so technical skills and also networking with people in technical industry, anything related to technology and coding and careers. And that's what Mac is here to help you guys for. So I think someone put our links for the socials in the chat soon. Feel free to follow them or to keep updated on our events. But other than that, I will get started with today's workshop. So let's share my screen first. And by the way, today I've created a document which has all the steps. So it's like a tutorial document. So I think Roy's just linked that in chat. So feel free to use that to follow along. That also has the links for all the assets as well that I'll be using in this. So yeah, let's get started. So the type of game that you're making, like I said, is an endless runner style game. So to give you an example, this is what an endless runner game looks like. This is one that I built earlier. So the idea is you just, oh, I died very fast. That's kind of embarrassing, but you just keep on running and new tiles keep spawning and you have to try and get a high score. So very simple, like Subway Surfers, I'm sure you guys have played before. So this game that I'm building, this is in an app called Unity. So Unity is basically a big game engine. It's I think the second biggest game engine in the world. And it's used to make a lot of games you guys have probably played. Things like Fall Guys, Among Us, Pokemon Go were all games that were made in Unity. So that's why we'll be using Unity today. So for those of you that might not have Unity already, you can just download Unity from the Unity website, which is right here. And like I said, I've got this notes document, which is linked in chat, where you can see all the steps for everything I'll be going through today. And there's also a link to the sample assets folder, which is all the assets I'll be using today. And this also has all the scripts I'll be using. So if you fall behind or anything, then feel free to use that. Right. So once you have Uni downloaded, this is what Uni looks like. You have a scene area here. So this basically is your context and everything that you're working with. Then you have this scene area here. So this is the editor. So this is where you can play around with anything, move things around, change the size, rescale them. That's what this is for, the scene editor. Then you also have your game screen. So a game screen is where you can actually play and test out how your game works in real time. And then you have this area here, which is for the projects. So all the files and everything that we use are generally kept in these folders. So in Unity, as developers, the files that we like to use generally have pretty standard names. So materials, prefabs, scenes, and scripts. Materials refers to basically anything that we're using for design. So this could be like textures or colors or anything like that. You have prefabs, which is all about your actual 3D assets. Then you have scenes. So scenes, like I said, it's a different saved context that you can use. You might have a scene for like the first level or for a menu screen or for an item shop or something. Each different context is its own scene. And then scripts, which is, of course, your scripts. And over here is the inspector. So the inspector is where you can see all the components of a specific object. So here I've clicked on the player object and you can see all of its different components. Like it has a transform component for its current position. So I can change where it's located, for example. Then it has its renderer, its collider, and the script that's attached to it, and a rigid body. And I'll go through what most of these mean pretty soon once we start getting into the actual workshop. So that was just a brief introduction into the new layout and how to basically work Unity. Some more things to keep in mind. If you want to create any objects, you can click these three dots and then game object and then create here. So anything you might need to create, whether it's an object, light value, audio that you might want to play a video, a UI, a camera, anything you need to create at all is all over here. So this is a sample of the type of game we're going to make today. So let's get started with today's workshop on creating this. So to create a new Unity app, a new Unity game, you can just open the Unity hub and then click new. And when you click new, you can select the type of game you want to build. So Unity is very flexible. You can create 2D games, 3D games, and it also allows you to combine anything from animation to audio to scripting, anything at all you can combine in Unity. So that's why it's a really good game engine. So here we want to create a 3D game, give it a name, and then you can create it. So because it takes a few seconds, I've already created a new game here as an example. So this is our game screen. So like I said, I like to drag this out to the side just so you can see both the editor and the game together. Yeah, so again, we have all of our components here, but of course we have nothing here right now. So we can drag in the assets. So the link to the assets that I'm using is in that tutorial document I showed earlier. Once you have that downloaded from Google Drive, you'll see this. So these are all the individual scripts in case you need them. Or there's this whole Unity package, which is all the assets I'm using plus the scripts as well. So you can just drag this into Unity, import them all. So an asset is basically any type of object, material, script, basically anything that you're using in the game. So I've saved all this together just so that it's easy for you guys to follow along. So we have our prefabs here. Right, so just loading now. So we have, like you can see, a barrier object, a player object, the different tiles. So the different tiles is like the different floors basically with all the types of obstacles. So because I've just made it very simple for this one, it's just a barrier obstacle that's placed in different sections. So you can have one like the middle lane, left lane, or right lane. That's basically what's going on here. So we can see that when I imported this, it came with all the materials that I used to create those, the actual prefabs themselves and the scripts. Now in this workshop, because I'm going to be going through everything again, I'm just going to move all these to like a backup folder just for the time being, because we'll be recreating these. And all right. So just refreshing this. Oh yeah, for anyone that might have just joined, and if you need the link to this tutorial doc, by the way, let us know, we can put it in the chat. But all right, let's get started with making the game. So the first thing that we always need to do is set the scene. So to set the scene, the Unity already comes with one preloaded scene. All you have to do is basically just rename it. So if I go to scenes folder, you can rename it to anything. So I'm just going to call this like our main scene for the game. And this is the scene that I will be editing in. If you want extra things, like I said, like a menu screen or say item shop or a different level or something, you can create other scenes for that. But for this, we'll just have one scene, which is called the main scene here. Now the main scene comes with a directional light, which is the angle that the light will be shining on the player at, and also main camera, which is what we see in our game view. So for this, we have that. Now, the first thing that we'll do is we'll drag the player object here. Now, the player object, it already comes with a player script, but for the sake of this workshop, I'm just going to remove that so that we can rebuild that. So this is our player object I've chosen here. It's just a simple, very simple capsule. Now, the editor is really useful. So the editor is where you do any sort of, well, editing. So you can move your player around. You can rotate your player like you see fit. You can even scale them however you want. So this is what the editor is for. So like I said, you can move them around, you can rotate them, you can even scale them, and that's what the editor is used for. So in my case, I'm not going to change anything. I'm just going to leave it as it is. Yeah, so that's our player in there. Now, first thing we can edit is just our camera, just for our view. So when we're playing an endless runner game, usually you want to view down on the player so you can see like everything that's in front of it, like obstacles and that. So we can move that. We can move the camera. Now to move the camera, we kind of need to know where the camera is. So if you hover over this editor screen and press F on the keyboard, you can focus on that camera. Oops, let me just move this here. So we can see that we have our camera object here. So for this, I'm just going to move this up a little bit. So we're looking downwards on the player, maybe even angle it a little bit down. It's easier to see, so we can see our player there. And there we go. So we've got our camera set up and we've got our player. But obviously right now we don't have anything going for the player. So let's add some movement to the player. So to add movement to the player, we need a script for that movement. So to create a script, you can go add component. And then if you just, this has all different types of components depending on what you want to add, like audio, a layout. If you want to add some physics or some rendering, some UI, whatever you want to add, you can add from here. So in my case, you want to add a new script. So I'll just search new script. We can call that maybe play script 1. And that gets added here. So we can see that that exists in our play component. So any code you put into your player script will be run on the player. So that's in your assets folder. So I'm just going to move it to the scripts folder. And we have this here. So to actually edit the code in this, we'll have to use any sort of code editor that you have. So I'm just going to be using VS Code, but any sort of code editor should work. So when you open a code in Unity, you can use either Java or C#, but generally C# is the more popular one, only because it's not too difficult to use. I know a lot when it comes to coding, I'm sure you guys will use Stack Overflow a lot and all that. So yeah, I don't think you'd have much trouble with coding for Unity with C#, even if you haven't used it before. It's quite easy to learn and quite intuitive. So let me just briefly explain what this code is. So this code is, like I said, a C# script. It comes with first some basic imports to run it with Unity. Then any code that we put for our script has to be in this class here, which is this public class. So this public class comes with two components. It comes with two functions. You have a start function and an update function. So the start function is basically any code that should be called when the game originally starts. Like for example, if you need to get any components or set any important in-game variables or anything, you can do that at the start. Then update is a code that gets called as the game is running every frame. So this is where you can update things like you can move forward or move left or right or anything, any checks for that. That's what goes in this update function. So for our case, the first thing we'll be doing is just adding some basic forward movement. So to do that, let's first specify how fast we're going to move. So to do that, we can create a public float called move speed. And I've just set move speed to a default value of 15.0f. And I've made it public so that it can be accessed in the Unity editor. So one cool thing about the Unity editor is that any variables that you set to public in your code, you can actually access from Unity itself. So if you need to change this value later, you can just change it straight away from Unity rather than having to go into the code and then change it. So that's one cool thing about Unity. So once we have that variable, once we know how fast we want our player to move, then we can set our actual movement code. So movement code is something that needs to be called every frame to move the player forward. So we use this piece of code here. Now, just in case I forgot to mention, one of the most important things for any game object in Unity or in game development in general is something called a transform component. So a transform component is what is used to find your object's current position. So we can see here this transform component has an X, Y, and a Z position. Because we're in 3D space, that's why you need X, Y, and Z axes. So to access this position, we have to refer to this transform component. So that's what we're doing here. We're referring to a transform component and we're using the translate function. So translate function basically tells it to move in a certain direction. The direction we're going to move is forward. We multiply that by our move speed because that's how fast you want to travel. And we multiply that by time to delta time because we want to keep gradually moving forward. So that's why that's happened. Now, in case any of you don't know what a vector 3 is, a vector 3 is just any 3D vector, like let's say something like this. We have an X value, a Y value, and a Z value. So a vector 3.forward, for example, looks like 0, 0, 1 because you're moving 1 in the Z axis, which is forward and back. So Y is up and down, X is left and right, Z is forward and back. So a vector 3.forward just says that you're moving forward. So this would be our code then to move the player forward. So we can test this out. I'm just going to create a basic tile for now. And I'll just move this forward. Okay, So we can see if that works in game now. So press play. We can see our player is just constantly moving forward, which is what you'll see happens in any endless runner game like Subway Surfers, where you're just constantly moving above trains and all that, always moving forward. So that's the aim of this. So making forward movement is fairly simple, but one big thing that we want to be able to do in this game is move left and right. So to add left and right movement, we'll go back to our script. Actually, one second. So before I do that, actually, let me just add this in. So some of you may not know this, but I guess it depends on the type of endless running game you've played, but generally you have 3 lanes. You have a left lane, a middle lane, and a right lane. So the way to keep track of what lane you're in is usually through an index. So you can use something like index 0 to represent your middle lane, index -1 to represent your left lane, or index 1 to represent your right lane. And the way we switch lanes is by keeping track of this index. So if you want to move left, you'd reduce your index, or if you want to move right, you would increase your index. So that's what we need to do in our code, basically. We want to check for any left or right input through the arrow keys that the player would put. And then once the player's entered that, we want to change this index and then move based on that index. So that's the idea behind the left or right movement. So going to the code, the first thing that we need is a reference to the actual lane that we're in. So this is a private integer's current lane. So like I said, -1 to represent the left lane, 0 for the middle lane, or 1 for the right lane. Now the other thing we have is actually the lane size. So we want the player to know how much to move in each direction when we move left or right. So that's why you need this lane size. Again, I've set this to 3.25 as a default value, but if you go into Unity, and if you go into the player, you can see that the variable shows up here. So during the game, if you feel like you want to change it up, if you feel like the lane should be wider or narrow or anything, you can just change this value straight here. So let's go to this code. So once we have that, the other thing we need is to know if we've moved or not. So to know if we've moved or not, we can keep a Boolean value to keep track of that. So we can create a variable called moved. And for now, I'll just set it to false because we haven't moved in any direction. And the next thing we can do is actually check for our direction. And by the way, just to save a bit of time, I'm just copying and pasting the code from the tutorial that I wrote earlier, just to save a bit of time. Oops. So how this works, how getting movement works is we use this function called getKeyDown. So getKeyDown basically registers every single time you press any keyboard button down. And when you use a keycode.right arrow, it's saying that we're waiting for the right arrow button to be pressed. So if the right arrow button is pressed, then it's registered a movement. The movement that we want is moving right, which is why I'm incrementing current lane to 1 and also setting move to true since what we've moved. Now, one check we have to do here is to check that we're not already in the right lane, because if you're already in this right lane here, it doesn't make sense to move right again. So that's what this check does. So if the game registers a right button, and if we're not already in the right lane, then we can move right. Same thing for the left side. If the game registered a left arrow pressed, then we can move to left as long as we're not already in the left lane. So that's how we decide what lanes we're actually going to move to. Once we know what lane we're going to move to, then we need to do the actual switching lanes. So we need to know what our position would be in another lane. So this is the code for that. So what we do is you can create a variable for target pos. Again, it's a vector3 since we need to specify its x, y, and z values. In terms of z and y, here, our y is going to stay the same because right now we're not jumping or anything. So our y won't change. And also the z, we don't need to change the z because we're moving left and right only. We only need to change the x value. So here, we're basically just copying the default or current z and y values into target position. So these are just the 2 default values. Now what we do need to change is the actual x value. So to change the x value, first of all, we need to check what lane we're moving to. So if we want to be in the right lane or the left lane. So if we want to be in the right lane, then we have to increment this by lane size times vector3.right. Or if we're moving to the left lane, we will use vector3.left. So vector3.right, again, it's just a variable that looks like this. It's just a 3D vector, so it's just 1 in the x direction, so +1 in the x direction means on the right, and for left it would be -1. But Unity makes our life easy and just gives everything as a vector3 dot method so that it just makes coding a lot easier. So this way, we know where to move in the x and y direction. So that's that part. And once we know where we need to move, then we can actually move to that position. So we don't need this anymore. So that code that I deleted is just the same line here, basically. So if we haven't moved, then we want to keep on moving forward. But if we have moved, then instead of moving just forward, we need to also switch sides. Sorry, switch lanes. So to do that, we can use a vector3.lerp function. So lerp, it's this complex mathematical function, but we don't really need to understand that for our case. For our case, all you need to know is that it moves the player smoothly from your original place, which is our current position, to any sort of target position you specify, and we do that over time. And this is just speed for how smooth you want it to move. So once we've done this, the player, when we register left or right input, it will calculate what position we want to move to, and then move to that based on the input. So let's have a go and test this out. So you can see that when I press left and right, the player is moving left and right as they should. And I forgot to turn gravity off. So right now, the player just fell off the end. But we can see that the left and right movement is happening. So hopefully that makes sense. Again, like all the steps are in that tutorial doc if you need, or if you do have any questions, let me know or put in the chat or something. But that was left and right movement. So I think everybody knows that the main like fun thing that comes out of an endless runner game is being able to jump over different types of obstacles. So we've done forward movement, left and right, but haven't done jump. So next one I'm going to go through is how to do jumping. So when doing jumping, we have to use something called tag. So tag is a new component which I'm about to go through. So if I look at any tile, let's say tile 0, they have this thing called a tag. So tag here, I've created a tag ground. You can just press add tag plus and then create one called ground. And we tag it with ground. So the reason we do this is because the player might collide into lots of objects. It might collide into the floor, into the barrier, or if you have other things in the game, like you have coins or something, or I don't know, trains in the case of Subway Surfers, then you would have a different reaction that you will need to do for each collision. So that's why we use tags to specify what a specific object is. So this time I'm using the tag ground so that whenever the player is touching this tile on the floor, we knows that the player is on the ground. The other thing we need is this thing here called a rigid body. So rigid body is a really cool thing about Unity, which is the built-in physics component of Unity. So when you use a rigid body, when you add rigid body, that's when you're adding any sort of physics. So you can add gravity or forces or anything like that. And one cool thing about Unity, because it does all this physics calculations and functionality for you, all we need to do when jumping is just tell the player to add some upwards force. So that's what we'll be doing in our code. We just need to basically reference this rigid body and then add some force to it. So if I go to the code here, again, the first thing we're going to need is some references. So, oops. So we're going to need, first of all, the height of each jump. So that's just a public variable called jump height. Again, made it public so that you can just access it straight from here and play with the values as you want to. Then we have a private rigid body RB. So this is a reference to the rigid body component. So when you want to reference a specific component, all you need to write is the component, the name of the component before the variable you assign to it. So in this case, a rigid body. And we can also create a private bool for is grounded. So if the player is on the ground, then this will be true, or if the player is on the ground, this will be false. And it's set to true at the start because at the start, the player won't be jumping. So once you've created these variables, then the first thing we do is actually access this rigid body component. So we create a variable for it, but we need to actually do the reference. So the reference, we can do that at the very start of the game, which is just a simple get component. So we're just telling Unity to get the rigid body component of the player and store that here. So this way, whenever we want to do any physics, like add any forces, you can just add that to the RB value. So let's have a look at doing the jumping movement. So when we want to jump, the first thing we're going to need to do is we're going to have to actually get the jump input. So to get the jump movement, we can use, again, input.getKeyDown. So waiting for when a button is pressed, and the button that we're looking for here is the up arrow for jumping. So this will wait until the jump button is pressed. Once the jump button is pressed, then we need to check if the player is actually on the floor, and if they are on the floor, then we can make them jump. And like I said, when you want to jump, all you need to do is just add a force to that rigid body component. So you add the force. Now, for the force, you have to specify the direction of the force. So because we're jumping up, we'd want an upwards force and multiply by how high we want to jump. And then we add this thing called force mode.impulse, which basically means that you want to apply the force instantaneously to the player. And of course, setting is grounded to false since the player is no longer on the ground. So this will therefore do our jumping. However, so far, the issue with this is once the player's jumped once, is grounded will be false, and then we never set it to true again. So the player won't be able to jump again. So the only way to make a player jump again is by knowing if they've hit the floor. So to know if they hit the floor, we have to introduce a new type of function, which isn't start or update, but it's called the onCollisionEnter function. So onCollisionEnter is a function that is called by the Unity engine every single time your object hits another one. So again, going back to our game, this will be called when the player hits a barrier or hits the floor or hits anything at all. This onCollisionEnter function is called. And whatever it's collides with is this other input here. So in our case, we just need to check if whatever it collides with is the ground. If we see that it's the ground, again, we just check from the tag that we made earlier. Then we know the player has to be on the ground, so we can set is grounded to true if it's not already. So that should be our code for jumping. So we can give it a shot here. We see the player jumps again, and you can't double jump. And of course, we don't have enough tiles yet, so that's why the player keeps falling off at the end. But the basic jump functionality seems to work. And like I said, if you want the player to jump higher or anything, feel free to play around with these jump height variables and things like that, just to customize it a bit. So that was all the different types of basic movement you can do: forward movement, left and right movement, and jumping movement. And now we can move on to something else, which is dealing with the camera. So far we've looked at how the player moves, but if you notice, whenever you play any type of endless runner game, you want the camera to sort of follow the player as we go along. So for that, we're going to edit our camera. So the camera has a lot of interesting components. One is that you can set what you want the background to look like. So you can set it to be a specific color, like a solid color, like say you want a blue background, or you can even set it to something called a skybox. So skybox is just sort of a 3D background. So if I go back to the end product, mine, it looks, there's this sort of like space Milky Way style background here, which is called a skybox. So if you want to use a skybox, feel free to just download one from online. If you just search up Unity free 3D skybox, you can generally find heaps, and then you can drag it in, or you can set it to a solid color, or you can just leave it as this default, which is what I'll just be using for now. Now, we want to make the camera follow the player, like I said. So for that, we're going to need another script. So I'll create a new script component, and we can just call that something like camera script. So now the camera has a script, and I'll just move this into the scripts folder. And now we can open script. Okay, and again, we have the same start and update functions. So to move the camera to wherever the player is, we're going to need to know where the player is, and we're going to need to know how far the camera should be from the player. So we can use two variables to store that information. We can keep a track of the player's position using the player's transform component, and we can keep a track of the distance by creating a vector3. So that's just, again, a 3D vector. So to store the x distance, y distance, and z distance of the camera from the player. So once we have that, then at the start, we can set a specific distance. So at the start of the game, earlier in the workshop, I set the camera's position to what sort of looked like a good angle. And we can keep this consistent throughout the whole game by storing it at the very start of the game. So at the very start of the game, whatever our distance is, so our current camera position minus whatever the player's position is, that's the current distance. And we can keep that constant throughout the game by storing it in this distance variable. Now, the next thing we need to do is in each frame, we want to update the camera's position to match up with the player's position. So this update, this, like I said, is called once per frame. So Unity gives you a lot of flexibility of when you want things to update. If you want to update them during the frame, before the frame, or after the frame. Now, usually when we're working with a camera, it's better to let the camera update after the player does all of their movement. So we can use another function called late update. So what late update will do is it'll allow the camera to basically update its own position after all the rest of the frame, so all the player's movement has already finished updating. So that's why we're using a late update function here. Now, in this late update function, we want to basically calculate the camera's new position. So we create a new vector3 for that, so called new position. So this vector3, we're going to keep the x and the y position as they are, because again, the camera isn't moving sideways or up and down. The camera is only moving forwards. So the only thing that we need to change is this z position. And the z position is, again, we just want to be wherever the player is, but be however far back we specified at the start. So that's how this new position is calculated. And once we know this new position, again, we're just using the same function as earlier, a vector3.let function, to move the camera from wherever it started to wherever we want it to go, and to do this gradually over time with a speed of 60. So if I go back to the code now, and if I run it, you see that the camera is actually not moving. So that's because in the code, I specified that we want to access the player's component, but in Unity, we haven't actually done that. So one cool thing about Unity is over here, you have your console, and this console will output any errors or any warnings or any improvements that it thinks that your game needs. So here we can see that the error is that the variable of camera script 1 has not been assigned. So this player here. So all you need to do is drag the player to this, and we see now it knows who the player is. So now it knows that that's the player that the camera needs to follow. So let's test this out, and we see the camera is clearly following the player. Okay, so that's the basics of an endless runner game, making all that happen. Now, one thing that is obviously really important is obstacles. So in terms of obstacles, for this, with the assets that I have, it's just a very simple barrier. But of course, you can create your own assets. So 3D, with Unity, it can use basically any sort of 3D object. You can create a 3D object in another piece of software like Fusion or Autodesk, or basically anything that you can create 3D softwares in. You can save it as an OPJ file, and then you can use this in your game. Or you can even search up online free 3D Unity assets and stuff. There's heaps of things online that you can use. There's even a Unity store. If you go to the asset store, search online, Unity has its own asset store where it has a bunch of free and paid 3D assets that you can use for your game. So yeah, if you want to use like any sort of advanced obstacles or different types of obstacles and stuff, feel free to go and get them from online. You can actually create them in Unity itself, but it is a bit limited in terms of what you create. So 3D objects, You can create a cube, sphere, capsule, cylinder, a plane, and there's a few extra ones. But basically, these are the only things it has available. So if you want to create anything, like I did the barriers here, you basically have only these 3D objects to play around with. So that's why most of the time when you're creating like a proper game with like proper objects and all that, it's better to make the 3D object in another software or download a free one that you can license from online and then use that. All right, cool. Let's keep going now. Yeah, cool. I don't see any questions or anything in chat, so we can keep going with the tutorial. The next thing is, like I said earlier, spawning the obstacles and the floor tiles. So right now, there's only 3 floor tiles, which are the ones that I've put over here. Oh, move that in front. There we go. So these floor tiles, we don't want to have to manually place them because you don't know how far a player will run, whether they'll die after like 10 seconds or whether they'll keep on playing for like a couple of minutes. We don't know how far the player runs. So what we basically need is a way to automate this process and keep the player keep the tiles constantly spawning as the player is moving. So we're going to have to create a script for that. So to do that, let's first of all create an empty game object. So this empty game objects are basically just free objects you can use for literally anything you want. In my case, we want something to manage the floor tiles and tell them when to spawn. So I'm just going to create floor tile manager. And to this, let's add a script. So let's add a new script and we can call this the tile spawn script. And again, just drag this into scripts folder. And we can edit this. So again, we have our start function and update function. So the first thing we're going to need in this code is we're going to need a reference to the actual floor tiles. So to do that, we have to create a game object list with something like this, public game object floor tiles. So in C#, in case you guys haven't used it before, to make a list, you have to specify the type of the list. So in my case, we're looking at different game objects. And you add these square brackets to keep it as a list, to specify that it's a list of them. In my case, I'm just calling them floor tiles. So if I go back to Unity now, and we go to the floor tile manager, you can see that this shows up here. Now, good thing about Unity is that when you want to specify your floor tiles and all that, you can do it straight from the editor here. So yeah, so I think one reason that I really like Unity personally is that even if you're not super strong with coding, there's a lot of the editing and stuff you can do straight from the actual Unity editor itself. So here, if I want to add the floor tiles, you don't have to do it through code. You can just simply add them to the list in the editor. So let's say I want 6 tiles. We want tiles 0, 1, 2, 3, 4, and 5. So this creates a list of all the tiles, and now that it's stored in this floor tiles object, I can access this straight from this variable in the actual code. All right, so with our floor tiles, how we're going to spawn them is basically we need to keep a track of wherever the position is that the last tile was spawned. So in this case, it'll be this one, and then we have to spawn it in the next spot. So we keep a track of wherever the Z position of this is and then add 30 to that. Now I say 30 because with the tiles that I've created, they have a length of 30. So it's a length of 10 actually each one, but because its scale is 3 here, it becomes 30. So if this tile is here, the next tile would be the same position X and Y, but the Z would be increased by 30. So that's all we need to do, basically spawn a new tile with the next position. And because we don't want to spawn like 100 tiles at the start to not blow up, like say, the memory of the phone or whatever the game might be running on, we want to sort of add tiles as the game progresses. So the best way is to keep a track of where the player is. Like let's say that you spawn a tile, maybe every time the player reaches within 3 tiles of the last one. So that's what I'll be doing here. So the first thing again we're going to need is the spawn position. So this is the Z spawn position of the tile. And of course, a reference to the player's component. So I'll just add that in now. So for tile manager, it needs to know who the player is, which is this here. Right, and now we have an access to the player as well. So we're going to need to spawn the tile. Now to spawn the tile, I've written a function to do that just to make it a bit easier so that I don't have to rewrite this code every time. You can create your own functions and then just call that spawn floor tile function wherever you want. So the spawn floor tile function, it does, well, basically that. It'll spawn floor tiles based on the index you give it. So this game object floor tiles, again, has a list of all the different floor tiles options that we have. So this will spawn one of them based on this index. So just do a spawn. In Unity, we use the keyword instantiate. So instantiate just means spawn. We need to tell it what to spawn, so which tile, where to spawn, and also we need to give it a rotation. Rotation, we don't need to rotate the tiles in any way, so I've just left it as transform.rotation. If you ever see transform dot, it just means keep the current one, basically. And of course, at position, we want to spawn it at transform.forward, which is again a vector 3 that looks like this. Sorry. Looks like this. It's 1 ahead in the Z direction. And then we multiply that by Z spawn pos, so that increments this value to, let's say, the next position. So it'll be 30, then 60, then 90, and so on. So that tells us where the next spawning position is. And once that's spawned, then all we need to do is increment the Z spawn pos ready for the next tile. So that will keep spawning tiles. Now at the start of the game, I have these ones here just as default ones, but I'll get rid of them. And we can spawn them from the script. So if I say spawn floor tile, let's say 0, then spawn floor tile maybe 1, spawn floor tile 2. Now you can do this in a loop or however you want to randomize the starting tiles. For the sake of this workshop, I've just hard coded the first 3 tiles and the rest of them will be decided randomly. And they'll be decided randomly in the update function. So in the update function, so once per frame, we just need to check if the player is within 3 tiles. If the player is within 3 tiles, then we will spawn. And we'll spawn a random tile using the random.range function in C#. So this part here, it just checks if the player gets within 3 tiles by checking if the player's position is larger than wherever the next tile should be minus 60. So because the next tile is at 30 ahead of the last one, if we take away 60, then that tells you what the last 3 tiles are, and we just check if the player is ahead of that. So that should then be all. So if I go to game now, click play, we should see some tiles be spawning. So yeah, we can see that tiles are getting spawned. And as we're moving, the tiles keep generating, which is good news. So you can keep on playing this game. Obviously, the obstacles here are very basic, so I think people will end up playing for a long time. But yeah, if you decide to like turn this game to something more legit, I'm sure you'd be able to add like any other big type of obstacle. So that is how to spawn the tiles. In terms of how I made these tile assets, all I did was create basically a bunch of individual 3D game objects. So I created a plain tile here. So this is, so this is just a very, very plain tile. It's just a 3D object like cube, that's all it is, that I've just stretched in the Z direction. And then to that, I've added this barrier game object. So barrier game object here, I've just made a combination of a bunch of cubes. Obviously the legs, I've rotated them to make it look like a proper barrier. So that's how these were developed. And then once you've got these to create individually, you can just combine them. So for example, this tile here is just one barrier on the tile on the left lane, or this one here is one barrier on the tile on the middle lane, or this one here is one tile, but 3 barriers, one in each lane. Right, so that is our tiles ready, and the actual, so far we've got movement and we've got tiles, so that's sort of the main part of the game, the actual mechanics of the game. Now with Unity, like I said, there's a lot of other things you can add that's not just mechanic things, so it's not just movement, all that. You can add a lot of extra things like animations, UI, light, audio, and all that. So for this workshop, the next thing that I'm going to look at is how a UI works in Unity. So to create a UI, you need something called a canvas. So if you go game object, create UI, create a canvas, then on the canvas, you can put any UI object that you might want to be looking at. So I'll just move around so you can see this better. So first of all, let's create like a game over panel for when the player crashes into a barrier. So you can go create, again, I'm just right clicking on canvas, UI, and create a panel, and I'll call this game over panel. So with this game over panel, this is what we'll paste our UI elements on, for example, text or buttons or images or anything you might want to add. I might change the background color as well, just to make it a bit darker so it looks more like the game is ended. Let's say that, increase the opacity. Okay, cool. So that's what our ending game screen background will look like. And let's add some UI elements. So add some text. Depending on what version of Unity you have downloaded, you'll see either text mesh pro, or you'll see a normal text. It doesn't make a huge difference which one you use. There's a slight difference in functionality, but it's not gonna matter too much. So I'm just going to use a normal text TMP. So if you're using the TMP, it might ask you to import this, but it's generally fairly quick. This is just something that's in the newer versions of Unity, which you can be switching to. So we have our text here, and maybe you call this the game over text. And then in its components, there's an area here to edit any text you might want to put. So let's say game over. And let's say we want that to be a lot bigger. Yeah, if you want to resize something quickly, by the way, if you just hover over the word that you want to change, you can just slide left and right to change the value. So let's say I want this a lot bigger, maybe that size. Let's say we want it bold and maybe centered. And again, I'll just press F to focus on this. Oh, wrong side. And I want some one line, so I'll just scale the length of this and maybe move it a little bit up to the top of the screen. Yeah, that looks center-ish. So that's the first part. We can also add some buttons, let's say like a restart button. So you can, again, right click, create UI, create a button, and let's call this the restart button. Now, in a button, again, all its components come pre-made. The only thing we need to add is basically a function here to tell it what to do. And also we can change its text. So if you click the down arrow, you can see its text. So we'll call this restart. And again, maybe I'll make it bold. Oh, it's already centered. We can change the color of the background. Oh wait, that'll be over here, sorry. Oh, if you click on the button, you can change its background. So let's say we want maybe something that looks like green to restart. So that's a restart button. Let's also add maybe a like exit button. Again, I'll set its color this time to maybe red. And then we can replace the text to exit. Okay, now obviously the buttons are overlapping each other. So again, all you have to do is just move it using the editor. So I'll move the exit button down, keep the restart button where it is. I think that's fine. So that is a very, very simple UI. Obviously, this is a very simple UI, but you can make more advanced ones using a different functionality that Unity offers, which you can learn about if you follow like other more advanced tutorials. So that is a simple UI, but you'll see that the UI kind of it's always on right now. So we need a way to control when the UI will turn on. So to control when the UI will turn on, we can edit. We want the UI to basically come on every time the player hits a barrier, because that's when the game over screen should come on. So to do that, we want to go to our player script again. And we want to create a new reference to that game over panel. So over here, you want to create a reference to a game over panel. Again, it's a game object, so I'm going to specify game object and create a reference to that. So I'll just move that here. Here's our player. We drag the game over panel onto it. And then in our player script's code, we can specify when we want to turn that UI on or off. So to turn that off or on, there's a very simple set active function we can use. So you just get the panel, we want to set it to, we want to set active to false. So basically we don't want it to show up at the start of the game. So we can set it to false. We do want it to show up when the player collides with the barrier. So let me copy this. So earlier we did on collision enter, and we checked if we collided with the ground. This time, what we can do is we can check if we've collided with the barrier. So if I go back to this barrier object, it's given the barrier tag. So all we need to do is just check if this time we've collided with the barrier. So again, other.collider tag, if the tag is barrier, then we can set this panel back to true, so we can make the screen show up. Also, we're going to stop the player from moving, so we have to set the time scale to 0, so it resets the time. So this should stop the player from moving. So if we test this out, we can see that the UI panel showed up and the player hit an obstacle, and it's also stopped moving forward. Can't move anywhere forward. But what you will notice is that the buttons don't do anything. So to control the buttons, similar to how you create a for tile manager, you kind of need a buttons thing, something to actually manage the button events. So let's create another empty game object. Call this button events. And we'll add a script to this. And we can call this button script. Let's drag this script. Again, we have our button event script. So in the button event script, the aim is we'll just put whatever functions we want our buttons to do. So the first function that we would want is a restart game function. So we can put this here. We have a restart game function. Oh, before we do that, we need access to the scene manager. So we'll just add an import statement. So this is just a scene management library, which is used for scene events. So again, remember how we're using the main scene here. Basically, when you restart the game, what you're doing is you're just reloading that scene. So when you restart game, we can just call the load scene method of the scene manager, and we tell it what scene to reload, which is our main scene. So it will reload this scene. So that's how this restart game function works. Then we can also add one for the exit. So for the exit game, Now, if this was like a proper game, like it was a packaged application on like a phone or anything like that, or like a laptop, then we would use application.quit to exit the game. But because right now we're in just the Unity editor, all we need to do is set the isPlaying variable in the Unity editor to false. So this will exit the game for now. So if I head back to this, I can start playing the game, and let's say that we crash into something. If you exit, oh, we don't do anything right now. Yes, because that is one thing that I forgot that is important. Once you've created the actual functions over here, we need to actually specify the function to use. So we want to just add the function. Again, this is based on our button events. And the function was our restart game. Yeah, and then an exit button as well. We want to add button events to exit game. Okay. So see the player is moving. If I crash into something, we can exit, which worked correctly. Let's also try restart while we're here. And we see the game restarted. But what you'll notice is that we're not actually moving anywhere. So time in Unity is very important. When you restart the game and you reset the time, then when you load the scene again, you need to reset the time once again. So if I go back to the player script, over here, we set the time scale to 0. But what we need to do at the very start of the scene, then again, is set the time scale back to 1. So this will restart the time. So let's give this a try. Crash, restart, and we can see the player starts once again. All right, so that is a basic UI. So now we've got a basic game mechanics, basic tile spawning and obstacles happening, and also a basic game overall UI which you can use. So like I said, there's a lot of flexibility. I've just given a brief introduction to sort of all the different types of things that Unity offers, and obviously these can get very, very complex. One other thing that is always very fun to have in these sorts of games is a score. So we can also add a score. So let's add another element here, which is a score element. So that score element is just going to be based off text. Now I'm just going to use the legacy text because I want a very, very simple text for score. At the start, the score is just 0. And let's make that a bit bigger actually so you can see it. All right, we want to add here. Ooh, actually, can't really be seen. Let's drag that into the game over panel. And we'll set the color to white. Okay. Oh, I don't know why it's not showing up. All right, let me try this text. Oh yeah, there we go. Okay, don't worry. The legacy one must not be working anymore. Solve score 0. And we move that to maybe the top here. Maybe set the size a bit smaller. So this is our score, and we can update this throughout the game. So let's go back to our player script. Now I'm just adding this in the player script because our score is going to be updated as a player moves. We don't want it to keep updating when the player stops moving. So it's still associated to the player. So what we're going to do is going to add another import statement to access UI elements. So that's just is here using uniengine.ui. And then we want to create a reference to that score text object, as well as the initial score and the game timers. This will be used to calculate the amount of time passed. So for simplicity, I'm just going to say the score goes up by 1 every second. So we can use a game timer to keep track of how long it's been and then update the score based on that. Of course, default score 0. So we have our score text. We have to store the reference to it. And that was this here. I'll just rename that to score text. And I'm just going to move it out of the game over panel so that it's displayed always, not only when this game, well, not only when the game over panel is there. Okay, so multiplayer. I will drag score text. Oh, oops, I moved it out. Okay, it's not letting it. Yeah, I think I might need to create. Let me try the legacy text again. Yeah, there's a bit of slight difference in functionality between the new text type and the old one. Let me see if this will work. Okay, let's this one through. Let's see, this is just score 0, white. Font size bigger, we're going to move that. I'm going to keep that top. Okay, oh, don't know why it's not showing up. Okay, oh, anyway, I'll come back to that. Going back to the code. What we want to do is we want to set the score to 0 at the start of each game and also the score timer. So you can add this code in. Game timer equals timer delta time. So this just sets the current time. Again, if you ever want to access a time in Unity, it's just time.delta time. And then we just want to set the score to 0. And then what you want to do is update the score every second. So we'll just add this here into the update function. So updating the score, what we do is you increment the game timer with whatever the current time is, and we check if the new game timer has passed 1 second. If it's past 1 second, you can increment the score, replace the score text, and then reset the game timer to 0. Then again, in the next frame, it checks if the time pass has been 1 second or not. And this way you can update the text every second. Okay. Okay, and give me 1 second. Yeah, I'm not sure why this isn't actually showing up. A little bit weird. Oh, anyway, if I go back to the original game that I had, this is what it should look like. So we have our score text here. It should show up like this. So I don't know. I think there's a slight issue because I've used the text mesh thing, but yeah, I don't know. Unity's a bit weird like that. Basically, this is what it would look like. So if I run the game, then you can see every second the score goes up by 1. So it's going 1, 2, 3, 4, 5, 6, so on. And when you crash, it'll stop. And if you restart, score gets reset back to 0. And that's that. All right. So I guess that covers all like the main aspects of a game. We have all the different movement mechanics. We've gone through UI, and we've also gone through basic scoring. So yeah, again, not sure why it's not showing up there, but it should. So that is sort of all the main parts of the game. And like I said, you can make it can add some like nice vibes by adding a background or a skybox or something. And obviously, if you want to improve this game further, I would recommend there's a lot of things you can add, like adding start menu, or adding like a coin object to collect, adding an item shop. Yeah, adding like swiping if you want to make it like a phone app or different types of obstacles. There's a lot you can do. So Unity is very flexible, and yeah, there's always lots of tutorials online and lots of tutorials you can follow. Like I mainly use YouTube ones, but you find lots of ones that Unity have made themselves on their website, or even Stack Overflow I know has a bunch. So there's a lot out there, and I'd recommend, like, if you want to get into game development, Unity is definitely one of the best to get started with. There's also Unreal if you guys want to try that. I personally haven't worked with Unreal, so I can't give you any opinions on that, but I know Unity is really good for game dev. I've worked on one which is like a very simple first-person shooter. Did one which was like a maze style game where to find your way out of a maze, and of course this one, very simple sort of Subway Surfer style. But yeah, you can find assets online. In terms of assets, if you go to the asset store and click search online, it takes you to the Unity asset store. So Unity asset store has a bunch of free assets that you can use, like player characters, animations that you might want, terrains that you might want to use for your game or anything. But of course, you can always search online on Google. So I generally just search like free 3D player object or something, or sometimes I've made my own using some 3D modeling software, but that's only for very simple ones. I can't say I'm very good at that. So yeah, I guess that's sort of all that I had. I don't know if anyone has any questions, but if you do, feel free to ask me. Otherwise, if you missed any of the steps and stuff, like I said, that's all in the tutorial. So that is, yeah, I guess we're finished a lot earlier than I expected, to be honest. But yeah, I guess that is all. Any like questions or anything, or any feedback as well, let me know. Otherwise, yeah, I think that is all for today's session. Thank you for everyone for coming to this, and hopefully you learned something about 3D game development. All right, I guess I'll end the recording there. Thank you, everyone.